Test, test. Okay. start again. So, my name is talking about the internal assessment in the new IB courses. Compared to before, one of the differences is that it's taking longer. It's now 12 to 20 pages spaced, and previously they didn't specify double space, but previously it was around 6 to 12 pages. So, and it's assessed using 5 criteria: presentation, mathematical communication, engagement, reflection, use of mathematics. It's very similar to the previous courses. And for the two new HL courses, they have the same criteria, and for the 2 SL courses have the same criteria. There are a lot of similarity in these 2 criteria. The only difference in use of mathematics. So, criteria and presentation. A coherent exploration to follow and meets its aim. This refers to the structure or framework, including body, conclusion, and how all the different parts link to. So it's about able to follow the logic, and everything makes sense. Precise exploration does not show irrelevant or unnecessary calculations, graphs, or descriptions. So, let me try to improve the audio. Let me make it best. Okay. So we're talking about criteria in a presentation need to be coherent and concise. So it's like an essay. It needs to be compelling, organized. Criterion B is mathematical communication. To what extent the student has used appropriate notation. So calculator and computer notation acceptable only if it's computer generated. Take a screenshot of a graphing calculator, then you can use calculator notation. But if you're just presenting your work, for example, if you're typing it in a document, then you need to use proper math notation. You need to define key terms, variables. You definitely have to define terms that are outside the syllabus, but it's also a good idea just to briefly mention the topics in the course that you'll be using. Example one, not being labeled. So if you just have a graph, even though the plot might be creatively made, if you don't label the axis, it could be given a 1 for some relevant mathematical communication. Level 4 can be achieved by using only one form of mathematical representation. It's not a variety. It can be a single type of representation, as long as this is appropriate to the glory. For level 4, any minor errors that do not impair clear and the big one is personal engagement. There's a lot of misunderstandings. See, this is the big one, personal engagement. It sets the extent to which the student engages the topic by exploring the mathematics and making it own. So a lot of people say, oh, I really like this XYZ topic. I was very passionate about it. I started reading about it since I was 5. Ever since I was a little kid, I wanted to be become someone in this field. I always want to become a scientist. That does not really, that is engagement and it's personal, but it's not the one that I'm looking for. IB is looking for you to interact with the mathematics of the exploration. So it can be recognizing things. It includes independent thinking or creative thinking. Present ideas, exploring the topic from different perspectives. So it's like a way of where you're looking at different viewpoints, making testing predictions. Additional examples of levels are given, which I don't have. There must be some evidence personal engagement not sufficient. Team merge comments, a student is highly engaged. So the teacher can say, oh, so and so was very engaged. Textbook style explorations or reproduction of readily available mathematics are unlikely to achieve the higher level. So even if you talk about some advanced undergraduate mathematics, some advanced calculus, you're not really demonstrating personal engagement. And we'll come back to this. Part D is reflection. The reflection, it's a topic in a lot of the IAs. It's about commenting on your own work. And it's a method for you to explain your reason behind creating such a work. So we're looking for meaningful reflection or critical. Meaningful reflection may be linking to the exploration, summarizing it, commenting on what you have learned as a student in the process of writing this 12 to 20 page essay. Critical reflection is related to the mathematics. It will often develop through exploration by addressing the mathematical results and how it students understand the topic. So not just how it impacts you, how it impacts your understanding of the topic. Ways of showing reflection are concerning one next. So this is what additional experiments, this is the limitations of this report is. Discussions, implications, results, strengths, approach, and perspectives. So a lot of different perspectives. It's in both engagement and reflection. It's very key. This is where the HL criteria diverge. So in the SL, it's use of mathematics. Let's look at some higher levels. Relevant mathematics. Relevant. I want to show I'm crazy good at calculus. So let me just put a one line in calculus. That's so you need relevant mathematics. commensurate, so at the level of the course. Mathematics is mostly correct. Again, this is for the SL applications and interpretation, where methods and approaches, good understanding and knowledge are demonstrated. The level 6, the highest level, is mathematics explored is correct, thorough knowledge and understanding. So, for the mathematics can be regarded as correct, even if there are occasional minor errors. So it's a lower standard for the SL students. Understanding must be demonstrated in order for the student to achieve higher than level 1. So you cannot just keep plugging in without explaining your time. Again, it's supposed to be an essay. It's not a long homework problem. Let's look at how HL is different. So HL says level 5. Remember in previous case, level 6 was correct. So mostly correct, partially correct is correct. And correct is errors, right? So at the HL level, correct is level 3. The mathematics explored is correct. Some knowledge and understanding are demonstrated. So it's not is partially correct, it's correct. So it starts at level 3, and you just build upon it. Good knowledge and understanding. So this is a lower standard than the SL level 6. Level SL 6 says thorough knowledge, understanding. And thorough knowledge and understanding. And level 6, it says the mathematics explores precise. It means precise mathematics is error-free and uses an appropriate accuracy at all times. So it means essentially no mistakes. This is the criteria. Now let's look at simple IAs. Give me a second to set that up. Okay. The great explore. Okay, so the great circle distance. Statement of task. So it's given overview. Therefore, the use of circle geometry will be in finding the shortest distance. Okay. These comments were given by the teacher who marked this IA. Yep. So it says related to personal interest. It's not exactly what personal engagement is about. It's written specifically for the previous syllabus. What is great circle latitude? So we have some definitions. Latitude. Figure 1 shows part of a world map. So we're explaining the problem. Map. We can take the road from A to south until C. So like C, and they go from C to B. The total distance traveled and C happen together. But if there's any straight road from point A to point B, then we can so it's showing like a right triangle-ish. If it's a right triangle, we'll find out. Okay, it's giving a useful explanation. This is more for criterion A in our case. It's not really communicating mathematics. But figure 1. We want to move from one city to another. We'll draw a straight line between these cities. So these can see in figure 2, where a straight line is drawn on the flat map. And if we locate the same straight line between both, the distance shown will not be equal to the distance shown on a map. It's going to explain why this is, because it's the spheres are not straight lines in the real world, because maps distort the world. Right? So a map is 2D, the world is 3D, so it distorts it. And its plane travels through the center of the Earth. So the distance calculated on the Earth's surface, fundamentally a spherical distance or a great distance. That's why you cannot just directly use Pythagoras. You have to involve this great circle distance. So to calculate accurate distance, the great circle method is used. Okay. So here it is. Straight on a globe, it's curved. Okay. How do we calculate it? We have two methods. So two methods, that's the alternative perspectives. Methods are not accurate because it's not an exact sphere. So once we have calculated the difference between the longitudes and latitudes of the two places, we can use these to calculate the angle A and the angle B. So we need these angles, so they're explaining spherical distance. Okay. We're seeing some inconsistencies between capital D sub ns and lowercase d sub ns. This is definitely it can be still considered correct mathematics because it is error if you go from capital to lowercase. This person explains, so delta sub ns depicts south different. The north-south distance and capital difference. So as a reader, it's not very clear to me what does it mean by distance and difference. One way to improve upon this is to use like a physics term, which is used. You can use displacement, or you can use grid circle difference, grid circle length, just to emphasize. Yeah. Okay, so formulas, and this is the Pythagorean theorem. Okay. They use like computer notation like SQRT. So I can do this in many word processing softwares. So that's a diagram. I'll be taking numeric to and be calculating, and then the second case is power count. Okay. So we're using radius of spherical. You have the data. If you're wondering what the C is, C usually means radians. You also have R radians. So again, it's not very clear what actual distance means. You can say the straight line distance, or you can say spherical distance. Okay, nice. A globe. We have some math. We're playing Anderson. So far there hasn't been, I didn't see a lot of explanations behind these other than the Pythagorean theorem. It just says, okay, here's a formula. It could have, because this is use of formula in the syllabus, where you convert the arc length. So theta equals to arc length divided by radius. That would have been a nice connection to the syllabus, because you're actually using a different formula based on something that's in syllabus, which is the definition of radians. So that would be nice to include. And they get 8% difference. Now we see section. Even though the percentage is small, but in terms of distance, this percentage is huge, as a difference around 1,000 large value. So it's giving some personal judgment to what the result is. It's not just saying, okay, these are different. It's saying I'm saying the difference is 8%, and here's why 8% is big. So the author does a reflection, and then on the results. So we have a second case, the other two cities. Okay, so I believe this is Cape Town, and this is Dakar. Someone taking geography, please correct me. So we get a similar formula here. As you can see, it doesn't really contribute anything new. It's just the same question, but different numbers. So as it's not as an effective use of space. A lot of people in previous syllabi, they used to say, oh, 6 to 12 pages. Okay, then I'm going straight for 12 pages. 12, 20, you're straight going for 20. You don't have to go to the top if you're just repeating calculations. So one calculation gets me to 12, so I'll just do 2 calculations that'll get me past 20. So don't do that. Just do essential, relevant mathematics. That's a very similar thing. It's not very accurate, as there's 5%. Yeah, it's just, it doesn't really say anything new. So 3% they give an explanation, but with 5% they didn't say anything. So don't do redundant or repetitive calculations. The second solution, the second way they did it, so they were doing alternative perspectives. Let's do the Haber sign or Haber sign. Haven't heard of this before. Two cities and the center of the Earth, so the same as the first one. Then we'll draw a line from the center of the Earth to both cities. We'll just find central subtended angle, which will be two-dimensional. Okay. Where Haber sign has sine squared and theta over 2. So variables are well defined, but it's not clear what it means. So maybe it hasn't really shown understanding. That's what I'm saying. But the communication is very well communicated. We have proper brackets. The equations, they're clear. It's clear, it's proper communication what it is. I'm assuming that's when you convert to PDF, that's on random code. I think that just says cosine theta. Yeah, that's the double angle identity. Half angle? Wait, what is this? So good communication, but bad showing understanding. Very nice to define the. It's very good effort to define these terms. Very clear. It's like a straight line distance or a surface distance. Good notation, good personal involvement. I wouldn't say it's personal. I wouldn't say it's good demonstration. I would say it's some demonstration where we actually did some algebra. Okay, so that's, you have the angle, and then you have this. It's the same for cities. Then I would say that there are too many decimal places. Yeah, just way too many decimal places. These not very sensitive on cosine, so usually 4 is more than enough for all your purposes. If you just want an 8% difference, you don't need 6 or 7 significant figures. So just use 4 maximum for sine. Otherwise, it hinders the presentation. It goes all the way to the boundary and stuff. It's too long equation to for someone to understand it in one look. Or even worse, write it this way. People think, okay, it's not a fraction. Oh no, it's just too long, so they broke it to another line. So so you had to make that complex. Okay, I'm just gonna use 4 decimal places. Keep everything the same. Keep everything short. Keep everything online. So that's better. That would be better. Math. Okay. Whoops. Sorry about that. But this is more accurate, so that's good comparison. 6%, previously it was 5%. For this one, the difference previously 5%. Does it good work by showing example? I mean, it's the same thing. It's still unclear what the two examples demonstrate, like how they're different. Okay, distance 5%, so it's the same thing. We know that any method to calculate distance will always result in inaccurate distance. It could be rounds. You say, oh, because we maybe by questioning our assumptions. So maybe by just how different Earth is from a perfect sphere. I gave people it was around 97% a sphere, but the author didn't say that. So maybe you're saying, okay, so how big would this make a lot of difference? Right? To examine the problem under different assumptions than it is to use one set of assumptions. And in times where you're not really seeing what's the point of doing two problems, right? So just an idea what you could add to your IA. In the past, when the technology was not that advanced, we can use GPS. That's reflection. Now distance can be calculated. There's always some difference between calculated distance and actual distance. Okay. Gradient can only calculate inaccurate distance. You need to draw. I'm not sure what that to lead of. High chance of math error. Don't say that. Do not say there's a high chance of math error. Okay. With 21st century technology, the error for error properly conducted, if you type everything correctly into a calculator or a spreadsheet, you will not get it. It will be human error, and don't say human error. Okay, even in your science IAs, don't say, oh, it could be wrong because I screwed up. Don't say that. Conclusion. This exploration was really fascinating for me, as I could link my exploration to the experience of life by applying my conceptual knowledge of mathematics to develop theories. Yes, this is what personal engagement is about: applying your knowledge to a theory or another problem. Okay, it's not about personal engagement. It's not about how much you like the topic. This cleared my doubts and made it easier for me to understand the concept of navigation. The help of geodesics to understand the spherical geometry and trigonometry in a better way, and could actually use it in my it does, from reading it, it does have an idea of what the student has a good grasp of most of the math. The Haber sign wasn't very well explained, but I can see with some of the easier mathematics, there's definitely some demonstration of knowledge and comprehension. Biggest lesson I learned from this research is that any work will put in your effort. Researching on it, okay, it's not exactly what. Oh, okay. Same thing happened during my project. Started a project, I was not at all confident on whether I would be able to complete my project. This is a process of saying how the exploration itself helped the person. It's questionable if IB will accept it, but it wouldn't hurt too much just to put it in there. Learned many new things and was finally able to do my project. So overall, I enjoyed doing this exploration through this. Not only I learned non-Euclidean geometry and broadened my view on math, but also it was a fun activity. I get information about different countries through exploration. Again, it's not very relevant, we have some key phrases they mentioned. So they're able to use technology with the help of geodesic. They're designing their own calculations to carry out, even though they took the formulas from somewhere else. And it shows some perseverance of overcoming doubts. Okay, so it's some good, a pretty, and then bibliography. Okay, so the previous 14 verse 20. I believe this was an essay. I believe this was essay. Okay. Previous 14. Let's see. Mathematics essay occupation. Let's see how it scores in our new 4 course. So let's go for coherence. We're looking for coherence and organization. Okay, coherent is logically developed, easy to follow, and meets its aim. Introduction describes the aim and the exploration that has a conclusion. So you see, it's definitely well organized. It's definitely clear from the subheadings and the headings. We have these elements. So I would say it's definitely at least well organized, but it is concise. It does not show irrelevant or unnecessary repetitive calculations, graphs, or description. It's a bit questionable whether it's a 5 or a 6, or whether it's a 3 or 4, because it does somewhat repetitive. Instead of calculating distance between 2 cities, it calculates 2 sets of 2 pairs of calculations. And it's showing through 2 methods, but the 2 methods, there are some redundant data being mentioned. So overall, I would say this is well organized. It is definitely coherent. These go hand in hand, coherent, well organized, and it's not as concise as it could be, because it's probably trying to meet, like I say, a page requirement. And so I would say this would be level 3, and this is at the both SL and HL level. Criterion B, mathematical communication. So some of the errors we're looking at were the equations were getting too long, and it wasn't making out in one line. But overall, the equations were understandable, and there was one case where it was a capital D with a subscript, lowercase either changed to a delta with a subscript or lowercase d with a subscript. So minor inconsistencies. The mathematical communication is relevant. We have the author drawn over the map and showing, okay, this is that length, this is this length, this is how we're going to calculate Pythagorean's theorem. So overall, I would say it's definitely define key terms, multiple forms of mathematical representation. This is true. Deductive method. Okay, that's good. Is it consistent? I would say it's definitely mostly consistent. Mostly consistent throughout. Probably 4. Maybe being too generous here. I would say that the key terms were not as defined as it could be. I was having a lot of trouble defining, distinguishing what distance So they only define longitude and latitude, but defining, when I say distance, I mean the spherical distance. I mean, like the straight line distance. That could be, it's minor details. 3 or 4, probably 3 or 4. Hard to decide. Mostly consistent. We'll look at, we'll just say it's 3 or 4. 6 or 7. Okay, these are the easy marks. Now we get to personal engagement. Standing personal, significant, some personal engagement. Okay. Oops. The student demonstrates authentic personal engagement in the expression that these drive the expression forward and help the reader to better understand the writer's intentions. Demonstrates authentic personal engagement in the expression in numerous stances, and they are of a high quality. It is evident that these drive the expression forward in a creative way. It leaves the impression that to understand the context of the expression topic, the reader better understand the writer's intentions. I wouldn't say it's yet. I would say the personal engagement is definitely there, but somewhat limited. Engagement. So the teacher mentioned they engage by rearranging a format. I think that's a stretch, but personal is it significance? Drive the expression forward, help the reader to better understand the writer's intentions. It's not sufficient that comes engaged. But let's see how they added upon their. So one of the engagement, I'm not sure if that's reflection in the next part. One of the engagement was that they compared the results, the 4 numbers they got, 2 sets of numbers for each pair of distance, for each pair of cities. But I feel like they didn't give significant personal engagement. Personal engagement. Thinking, presenting mathematical ideas in their own way. So these are just formulas that were given, like from outside sources, from different perspectives. Engagement, making and testing predictions. That's also engagement. It just doesn't feel like it just doesn't feel like significant engagement. So it's probably between a 1 or 2. 1 or 2. We'll call this 1.5. We'll call this 3.5. So that's 5. And then that's concise. So we're looking at 8 right now so far. Okay. Reflection. Limited reflection. Meaningful reflection. Commenting on what they have learned. Yes, they definitely have meaningful explanation. Meaningful reflection. Crucial, deciding, or deeply insightful. So they just says, oh, because I think to reach critical reflection, they need to analyze the assumptions more. So maybe they can say, okay, I said the Earth was not spherical. Let's see how much that would impact the results. Something to that effect. Just doesn't. This is a meaningful reflection. So we have 8 before. So adding 2 to 10 out of 20. Okay, and finally, use of mathematics. So SL. So previous case, it'll be 10 out of 14, 10 out of 10 out of 14 for SL and HL, and then the big part is using mathematics. So at the SL level, some relevant mathematics is used. Limited understanding is essential. What I think might give, might be, it may be limited. There's definitely limited understanding. Let's see. It says obtaining the correct answer is not sufficient to demonstrate understanding, even some understanding, in order to achieve level 2 or higher. So it's saying just because I got the correct result doesn't mean it's knowledge. So that's this whole TOK thing. For knowledge to be thorough, must be demonstrated throughout. So how much is demonstrated? We have to go back and look. We're thinking of partially correct, some understanding, knowledge understanding demonstrated. The mathematics correct. I would say it's, I would say mostly correct. Okay, the mathematics explorer is mostly correct. Limited understanding. Okay, so limited understanding mostly correct. We might average out to a 4 and say it's still 14 for the S level. But it feels weaker than 14. So probably evidence some personal engagement. Yeah, we'll say it's around 13, 14-ish. 13, 14, so that's the same as what the teacher gave them. Use of mathematics HL. Yeah, some knowledge and understanding is demonstrated. It's partially correct. There's a the mathematics is a bit it's not quite commensurate, but if you say it's commensurate with HL, then somewhat. But they did demonstrate the rearranging equation, so that was so could be at the HL level as well with the algebra. The mathematics is correct. Good knowledge and understanding are demonstrated. Yeah, I wouldn't say it's a good knowledge. Probably some knowledge. Okay, so this would be partially correct. Mathematics explored is correct. I would say, yeah, I would say this fairly well describes it. So probably like the 13. It might not be commensurate at the HL level. That's the thing. It could be a 12, and it could be 13 or 14. Let's see what the teacher said. Okay. Somewhat similar to what I give them, but this is in the previous syllabus. To follow. Okay. It's the same. I would say it could be. It could be the length could be kind of different focuses. Okay. There's good definition of terms. Yes. Geography. Just like distance. That's the thing. And just be clear what distances is. Definitely some personal interest. It doesn't warrant personal engagement. It does. It's probably like a 1. I said 1 or 2. Probably at some 1. Personal engagement is about playing around with math, so they need to be more clear about their hypotheses. This is what I from the equation. This is what I predict. So that both shows understanding, use of mathematics, and it shows personal engagement. So it's 2 birds, 1 stone. That I think there's definitely some reflection. And reflection out by comparing like the 8% to the 6%. This is meaningful reflection. So meaningful reflection, to summarize, could be just looking at additional routes of looking at the assumptions. Use of mathematics, relevant mathematics. It's thorough. It's thorough, but there's definitely some understanding. And it's definitely relevant mathematics. At the HL level, I want to say right commensurate with HL level. So where I give more. Okay, so get the second example. Let me give me a second. I should link in case anyone's watching. Off my. Give me 1 second. I'll be right with it. All right, let's make the. I'm back. Let's make the file a bit. Okay. This is about modeling a circle lens pattern. Place of the background. Rationale. Become interested in materials. Okay. However, content is and patterns. Okay. I search online source of companies that sold these lenses. This is something beyond interest. This could be the start of from an interest, it derived action. That sold these lenses and found endless designs which caught my eye. So this is not good personal engagement, but this is where we're looking for. This is part for we're looking for math, making hypotheses, that kind of stuff. With 9 problems, this isn't HL. Didn't say. I believe this was define what an annulus is. You don't at the HL we don't have to define what problems are, but you need to define. Do like an annulus, it's like a torus or in this case like a ring within like a ring. Yeah. Their vertices. Yeah, that's good. In the syllabus, it's a good mentioning. Diameter 15 millimeters. Creating a circular function. Okay, we're radius. Solve for equation for x plane using a geometric program. They could mention because it's not like a function, it doesn't pass through the vertical line test. Then he would minus. So that just like directly a link say I understand what I'm doing. Directly mentions the syllabus. Talk about. I guess it talks about. Yeah. So this is their work. Okay, y squared. Use of technology, GeoGebra. So background to graph the problems. I forget this is the best way for me to find any information. So the outer one is 15 millimeters. That's fine. That's it's personal engagement to and to come up with your own like estimates. So that's still personal. I rely on my eyesight to plot the points of intercepts. Meant that the location accuracy. So this is what I did, and then immediately reflection. So reflection doesn't. Looking accuracy of coordinates were compromised. Resulting vary radius values. Okay. Which did not satisfy requirement for circular function. Again, it looks good enough, but we'll see anything else. Equal distance. Okay. The radius in the circle might have been equal in reality, however, since the photograph, the so they're overlaying this on top of the circle they drew. Okay. Now the intercepts all seem to be close to be 3 millimeters, so I'll assume this. It's nice, but it's not yet confusing yet for the reader. Okay, they made this. Is that 15? 5, 2, 4, 6. What is this? I could confusing. This is 7.5. Oh, yeah, it's 15's diameter. So yeah, so it's 7.5. No, it's good. So this is 75. 75, and this is very good. Okay, I've worked with either vertical like this or horizontal like this. That's an interesting way to communicate the mathematics. Tilted parabolas require the rotation of axes. Yeah, like tilted is not a technical word, but it doesn't create confusion. Okay, I thought that would be too difficult to graph them all on one Cartesian plane. Another method to graph the rotated parabolas and found polar graphs. Okay, good. So this is and previously difficult. This is anticipating how the difficulty is something, and this is showing that understanding, demonstrating understanding. Okay. So yeah, I heard about this rose curves. Yeah, I can't draw them myself, but they're pretty. So you can graph them on your own and see how they look like. Standardized coordinates for expressing polar equations. Okay, so it's converting between these. Again, these are from text. So maybe we'll see some additional understanding like this. Choose my curve problem. I have changed from graphing parabolic curves to sinusoidal graph. It repeats itself. And also, like, a problem with this is that it doesn't round, so that's a challenge they have to overcome. Okay? But so they got the 9 part right. Did they say what equation they use? They'll mention it somewhere. Okay, so at least that's a start. Nice. Let's get them off at the center. Graph equals to 6.15. Some version. Okay. In order for me to graph all 9 petals, I have to let the graph meet at the origin. So since the has y-axis symmetry, I chose the sine graph. Symmetric equation for this curve. Yeah, 0.15 sine 9t. It's not very good results. Okay, this is reflection. I thought that by simply substituting all the size petals, yeah, can we all wish? You just try something and it works. Better than expected. Right. So this is about identifying a surprise element. Okay. There's a limit in understanding, which is also defined the understanding. So it's good to point out surprises. Yeah, the main part is that it shows engagement. Okay, by interacting with it. Think. Start with the origin. Again, I'll talk about that. You need to stop at the circle. Okay. There are lines passing through the circle. The word's vision will be hindered. Again, it's thinking about thinking of map of the, for lack of a better word, real life situation. Think about the contact lens. So about first try to solve the problem width of petal curves. I decided I'll create 3 parametric equations graphing 3 petals. Thought that this method would widen the flower petals because fewer petals means there would be more space for them to spread out. Okay. Let's see what I thought. So now this needs to be rotated, right? Like you could graph this. It's getting close. So you could say if you just rotate it 60 degrees, you could get that. You could get this. You could get the mathematics. This is personal engagement. The first equation starts with base equation. Yep. Change the model. Wait 3 paragraphs. For translation, so this is drawing connection to the syllabus, right? I researched about the rotation of parametric equation on that equation, so it's connecting outside material to syllabus content. For any parametric equation, I need to use KT equation with KT plus or minus delta. So this is a phase shift. Phase shifts are in the new HL syllabus. So we'll talk about phase shifts. If you haven't seen this before, make sure you study topic 1 and the adding sections of the same frequency, but different phase shifts and different amplitudes. So that's in the interpretation HL. Where they define what delta is, variable to be rotated. So it's how much to rotate this. Right. Using the background image for reference, use trial and error. This will be oxymoron. Okay, you don't use trial and error to find exact numbers. Trial and errors are usually for exact. Exact is not, let's just say exact is not the proper word to use here. And errors involved. Always, this is not a mathematical mistake, it's a reading mistake which will penalize for. The resulting equation is this, okay, so the didn't talk about, but it's all presumed at the same radius. From this, the base equation was rotated by, okay, so we're starting to getting very close. Now we just have to deal with this circle. They didn't show the other one, but I'm gonna assume that they were able to nearly overlap with the 3 trios, but except for the middle circle. So now the middle circle. This is showing good communication. So graphs, right? 12 pages. No, they're just showing a table, so it's more concise. So this is good for communication. The other equations, I could have rotated the figure. Figure 7, how I decided to choose the base equation of this. This is a sine cosine of both sinusoidal, so they're just like personal preference. It's easier. Simple rotation after finding equations through trial and error. Factorize the equation. Find yep, and all together. Right? So I show 1, showed some tables, and then they showed all 3 sets, and they used different colors, so this is good communication. Okay. For the petals, they modeled the pattern better than the graph in figure 5, okay, except for the circle. I just conducted more research, okay, more I'd like to prove the characteristics of a parametric rose curve so that I could better understand how to alter its shape. There's more to it. R equals to sinusoidal function effect constant a can be the equation in b equals a plus b cos kt. I have an idea of how to get rid of this problem, but let's see if they're thinking what I'm thinking. And it doesn't have to do with this a. Just the a just like the a will just move all the petals. I'll separate the petals, but you still wouldn't get the desired shape. You just move the point like outward. That's what I think would happen if you add an a. Okay, the constant a is a relationship with the b affects its largest, smallest part of the rose curve. So it's taking what they know from the a this applying to polar, affecting its shape, its relevance. To my problem in this expression, I'll be looking at the equations where a times a greater than b, because the rules that apply. Yeah. Okay. They cited it when a the origin. When a greater than b, the largest part of the graph is a plus b, the smallest. This is just this doesn't look right. Why would they? Okay, so they turned they turned the polar coordinates into coordinates. So okay, let's see. Origin, because the equation of the radius has no solution for 0. The constant radius has x and y axis symmetry. Adding a constant greater than the variable vertically translates the graph by a greater value. So above the axis it does not intersect it. The green graph is an example. Like blue graph in figure 10. This graph is still zero. So it's better than what I thought. It actually gets the petal shape that they're looking for. So this is what they're looking for. This is probably not what they're looking for. We're getting very close. We're not getting very close yet, but we're more than halfway there. Using the parametric equation, I will calculate these. Pattern. Okay, so looking at the pattern, the radius 6.15 minus 3. Okay, so this is review. Following rule for A and B using simultaneous equations. So these are here. Oh, so they're different. You get this circle, and if you add them up, you get this circle. Cool. Adding equations. Okay, yeah, just solve. In general, I recommend using, especially at HL, of using these precise fractions instead of just rounding to three significant figures. But there's some merit to it because you start with three significant figures. Sure. Third problem. Through graphing equation figure 16, I realized that only half my exercise. After 9th, follows greater position of pedals outside the inner circle. However, it does not model the shape of the pedal correctly. Okay. But the other one is shape, but the shape. Okay. Right. I decided to use a different type of parametric curve rather than a rose curve. I chose to model the pattern using ellipses. Thought of that instead of using one equation problem, to lead them to a more accurate recreation of the pattern. Okay, so begin modeling with pedal 1 from figure 6 using the equation of an ellipse. Look at the stuff. Seeing stuff I'm looking for. Okay, this is the vector notation of translation. So you need to be able to recognize this on a test on the translate 0 units and translate y like vertical the y values by 4. So moving up by 4 to the right, you get this. This is a notation you need to recognize. I just the inner circle. Okay, so you're getting this. You're able to meet the ellipse. I think they just did a very simple ellipse. Okay, sure. And whoa, how did they do that? That's what I think, restricting the domain. That's the idea first of restricting domain, and then just draw part of the pedal. Right, so it says this is where T goes, but the thing with this, I need to restrict for each ellipse. You just need to restrict the domain. Okay. Let me argue if you're only using ellipses, then it might not be relevant to do so many rose curves. But it's hard to say because it shows an attempt that's very reasonable. And it shows why it leads them to this. So it's a simpler approach, and it showed why that didn't quite work, and then why I had to resort to something like ellipses. You can argue both ways. I did that much where you can argue both ways. Different angles. Thought I'll have to replace the T equation with T delta. No, that just T plus delta just goes around this one ellipse. But I need to change different parameters. So I need to put the equation of ellipse in the form shown below. Have a particular word for it. Yeah. Equations, which I use graph paddle or simplified forms of the equations above. I use the new equations. I will get the same as those in table 3. Prove this on the right by letting 0 equals to 0. Pedal 1 have been rotated by 0 degrees. Okay, so they're this is the form they come up with. Right, so proud, it's nice to write your you can say it's very close, but stream is perfect. Okay. Again, it's very than what is a pattern formed by the cluster of random lines. Difficult for them to model petals accurately, as some part of the petals are hidden. Okay. So that considered nice separate equations were not symmetrical. Okay. Petals are not evenly spaced. Don't contradict yourself. So that my final model considered nice separate ellipses. Well, circle are ellipses. Then if you count circle as ellipses, then you know it's not symmetrical. The petals are not evenly spaced around the circle as the space between them varying width. We've got to unlikely a flat part in the original image to be asymmetrical. Yeah, they have like professional software to make the design. So this is just identifying strengths and weaknesses in the student's work. This is good. This is good. However, the issue is out of my control because I cannot do it. Okay. Final graph is the best. Okay. Right, because I did the art of mathematics. Okay. A lot about parametric equations and trigonometry. Yes, it is good personal engagement. It has inspired me to create other interesting parametric equations in the future, like and I do not know what they are. Although my models have been nothing extraordinary or world-changing, it's not quite the reflection they're looking for, but they're getting the reflection earlier. Oh, this is just conclusion. The reflection earlier scattered throughout the report, very nicely written. But again, it's just tie closely the idea of rose petals with the ellipses. To tie that in, I would say this is a very superb essay, very superb exploration, but now feels like stuff just to show I can do math, and now nope, I'm gonna use ellipses. Just feel irrelevant. The connection needs to be made more clear, and that would overall make this a nearly flawless exploration. The rose curves did not make it to my final model, so mind their geometric design. Is good. Always read that. Always last but not least, exploration taught me the art of patience as I changed each variable ever so slightly to make an accurate model. So you could also go more TOK, that's also fine. In their bibliography. I know what this to look at it again. I'm going to area. Okay, let's look at criterion. How is it? Okay, I'm gonna make it bigger. Coherence and organization. Does not show irrelevant or unnecessary repetitive calculations, graphs, or descriptions. I would say I think this is a very, very coherent, well organized. It's not as tight. This could still be a 3. even though the first so that's one of the downfalls of using frameworks. But I do believe I do believe this is still only a level 3. It's coherent or organized. Could very near. So the stuff just seems unfortunately. But otherwise, the connection between the even the mathematical connections, if they were justified, then of how the inspired this approach, then this could be a concise work. 12 pages essays may not be concise, so it's not about the length. Okay, that's that. Criterion B, mathematical communication. Overall, I think the communication is the mathematical communication is relevant. I would say it's relevant, but it's not concise. Okay, so it's definitely relevant. It shows clearly it's labeled. It's labeled X, Y, R, and T. We have charts, tables, a wide variety of stuff. I think most notational or symbolic mistakes. The key terms, again, a lot of like vertices, it's all standard terminology. Not needed to define other than say, okay, it's what a polar graph is. But understanding defined key terms were appropriate. Go back, look at it later. Diagrams, okay, good. Reflective method. I would say this is very good. Everything's in one line. The equations, a consistent use of 3 decimal places. That's a good a proper, like a good level of precision. So I would say this is a solid level 4. So right now there's this is already at least significant personal engagement. They're showing very a lot of research. I was confused about that. I did some research, figure out what the equations are, figure out lifts, which I never even heard about, but I guess they must have existed. Thinking independently, yes. So it's not someone has already made decisions. You're just saying how these are very well known. Taking they also need to model this. So there's definitely some problem solving, thinking independently, presenting mathematical ideas in their own way. That's very interesting. Exploring the topic from different perspectives. I think that's what they're trying to do with the rose petals, different perspectives. They can actually elevate this to like a nearly flawless. 20 over 20, but at 7 out of 8. And with this should be at 10 or 11. It should be a level 3. This is very it's strong evidence of this. Say outstanding. I think personal engagement and exploration in numerous instances high. So engagements are reflections that also count as personal engagement, and also I did research on this with the numbers. The core of this essay is that they play around with these numbers. I would say this is a 3. So a 10, 11. Reflection. The reflections, for the most part, it's scattered throughout the essay, but it's also smaller at the end. There's definitely meaningful reflection by looking at how their work, what part were hard. So that was reflection. I thought if I just do all of it, it's gonna be very hard. I don't know how to rotate them. That was reflection for one. The other part of reflection was looking at how their I did some of this. No, that's not reflection. What works when I tried rose petals, what didn't work. How was I able to, what do these numbers mean? So if I try these numbers, it makes a circle. If A is between 0 and B, this happens. If A is outside, this is reflection. So it's communicating, it's finding about these peripheral or even sometimes problem-solving strategies and thoughts, and communicating them to more feel to this experience, to at least the reading experience, so it doesn't feel like a textbook. This is very engaged. It all comes together. The students attempt to address the strengths and weaknesses at the end. Just how it's lit. It does feel it's either meaningful or evidence of critical reflection. Let's say critical reflection that's deciding or deeply often mathematical results, and on the student understanding, some ways to show critical reflection are considering what next. They did talk about what next, so how additional, they gave two examples of how these math different perspectives. So I would say, yeah, this should be a critical reflection. Although there could be rose petals to the ellipses. There could be like just that little push, like stronger theory. But that part will play a bigger role in use of mathematics. Okay, so right now they're at 13. Okay, I just deducted 1 mark for use of mathematics. So if this was a paper, then it's definitely relevant to the course. So it's at or above SL. Mathematics was correct. I mean, it's self-explanatory why it's correct. It does show the petals. Clearly, the person's able to, through the trial, develop a deeper understanding of the both ellipses and the rose petal curves. So it would be a solid level 6 at the SL level. We're looking for thorough, and it is through. This is what enhanced by adding these reflections throughout the text. Not only add reflection, it demonstrates knowledge and understanding. As far as I know, was an HL student, and so we're looking at it's correct, so it's at least a 4. We're looking at, is it demonstrated sufficient, and is the mathematics explored precise? Let's look at sophistication or rigor. Sophistication mathematics commensurate with the HL syllabus, or if was expected of an SL student. This is definitely beyond what's expected of an SL student by using rose petals. And I don't even know the polar curve for ellipses. So it's definitely commensurate with the HL syllabus. Include understanding what they did. And see underlying structure, looking different areas from that. That's something this is something that doesn't have a lot of text space to write, maybe only like a paragraph, but it might take like hours to really figure out how the rose petals and the ellipses are linked, and I think that would make it a solid 6. So it's unclear if it's a 5 or 6 right now, but to find that connection, it will be definitely a level 6. Clarity of logic language when making mathematical arguments and calculations. Mathematical claims relevant to the development of the exploration must be justified or proven. This topic circumvent trial and error. So that's one of the downfalls of these models. The deduction path isn't as clear to communicate as to solve problem algebraically, geometrically, or through any systematic means. That's a problem using trial and error, is that you don't have, you're lacking the rigor of reasoning. Okay. Students are encouraged to use technology. Okay, but understanding it must be demonstrated. So I think this person definitely demonstrated their understanding. Otherwise, they won't be able to replicate. They won't be able to replicate to a higher accuracy of the original diagram they're trying to replicate. So all in all, because it's not somewhat, it's only relatively, since it's just something that's very hard to find to get that level 6. But it could be a 6 depending on how. You could argue for both 5 and 6, but that seems to, by the nature of this, by the nature of modeling IAs, they often do lack sophistication and do lack in rigor. So I would say this is a 5 or 6. That is HL. So SL, it will be a 19 out of 20, and then the HL 8 or 19 out of 20. It could be confirmation bias, because I do know I know that, oh, there's more. Oh no, wait, that's the beginning. This is end. I know that there's got an 18, so it could be confirmation bias. Let me know. But that even though these two IAs were written for the previous syllabus, 14, these were moderated marks, and it shows that what the examiner is looking for hasn't quite changed since 2020 to 2020. Some of the IAs are still applicable, so read through them. So today we had an okay one for SL and a very good one for HL. you learn today.